In this module, we will briefly compare OICP protocol with other very common and popular protocol called Open Charge Point Interface. We will also present charging terminology and topology model commonly used in Europe. We will see how OICP and OCPI protocol fit into it. Open Charge Point Interface protocol supports communication between eMobility service providers and charge point operators. This protocol is free to use and is developed and maintained by ev-roaming Foundation. Details of OCPI protocol will not be covered in this course. We will only compare it with OICP protocol and point out the most important features. OCPI protocol works mostly in peer-to-peer communication model, and hub model is also offered in the latest 2.2 version. OICP, however, works only as a protocol between different partners and the hub. That influences a lot how you implement and integrate with those two protocols. In case of OCPI, you can start implementation almost immediately and test it against any other company solution. With OICP, however, you can start build a model and write some implementation, but in order to fully test integration, you need your own QA environment and access to Hubject platform. The next difference is modules versus services approach. In OCPI, you have multiple modules. Each module covers a complete functionality over a specific aspect, like, for example, charging sessions. The division of previously mentioned aspects is more granular, therefore it is more flexible. OICP, however, operates only on few services, which covers only the most important issues in eMobility world. The list of required services is not so big, so in theory, the implementation should be easier. In practice, you will need more services than it is required in order to be effective. The next technical difference is how the operations are modeled. In OCPI, you will use multiple HTTP methods in order to perform specific actions for EMP or CPO role. In most of the modules, you are not limited, and you can push your data as well as pull it from others. In OICP, you will use only post-HTTP method in order to model push and pull operations. What's more, those operations are not bidirectional and valid only for the specific role. For example, EMP can push authentication data to Hubject platform, but CPO cannot pull it. OICP protocol is definitely well-defined, standardized, and more mature. It's clear that Hubject does not allow to do everything, but every exposed operation is easy to understand, easy to implement, and covers most of the needs. The only drawback is that introducing any kind of change to the protocol is hard and takes more time. OCPI, on the other hand, is more flexible due to its structure and ev-roaming Foundation policy. They've built a community, which can suggest what kind of changes are necessary and what kind of solutions may be good to introduce in the future. One of the most important differences we have encountered is connected with previously mentioned authentication data. In OICP, CPO cannot pull EMP authentication data from Hubject platform, while in OCPI, CPO can pull it directly from eMSP partner. But why is that so important? Let's imagine that you build a complex CPO platform which integrates with multiple partners with OICP, OCPI, and some other protocols. You may have a situation where some end customer would like to start a charging session at your charging point with RFID card. You, as a CPO, need to validate if given user is able to do that. Therefore, you need to authorize the request in some eMSP partner. But how would you know which partner is involved? If you have eMSP authentication data, you can build a simple e-roaming table and know exactly which partner is involved. Unfortunately, OICP does not allow to pull EMP authentication data. Therefore, you cannot fully build that roaming table. If you receive a request and you do not know which partner is involved, you need to treat Hubject and its authorized request as a fallback. And if you have other protocols with similar behavior as in OICP, you need to perform a broadcast in order to authorize the request. The next thing is that OCPI offers more details about ongoing charging sessions, which is a crucial feature for other eMSP partners. Also, basic smart charging functionalities are offered in 2.2 OCPI version, while OICP does not cover this topic for now. The last thing is strictly business related. OCPI is more flexible. Therefore, it makes it easier for you to build your own business processes and business model on top of it. You can define your own rules and use functionalities offered to you in many combinations. On the other hand, OICP is designed to be compatible with processes defined by Hubject. So sometimes you need to be compliant with them in order to integrate and use full of its potential. Now I would like to present you a charging topology model which is standard in Europe. At the highest level, we have a charging pool, which is basically a location of given charging spot. Each charging pool may have multiple charging stations. You can think of them as a physical stand next to the parking spot. Each charging station may have multiple charge points, which represent supply equipment needed for charging. For example, we may have two parking spots next to the one charging station with two charge points. It allows both of the electric vehicles to charge at the same time. At the lowest level, we have a connectors, for example type 2. Each charging point may have multiple connectors, but only one can be used in the moment. As you can see, OCPI and OICP are not fully compatible with European standard. OCPI at the highest level has a location, which can be related to charging pool. Charging station level is omitted, so the next level is ev-cpo. ev-cpo in general is the same concept as a charging point, as far as I recall there are small differences. At the lowest level we have a connectors, which is almost the same as for European standard. When it comes to OICP, Hubject introduced a similar vocabulary to the protocol by adding charging pool ID and charging station ID, but those are just IDs. Location is still a part of an ev-cpo and is not separated out. Also, OICP does not have a separate model for connectors. Those are present as the plugs in ev-cpo data model and are not separated as an entity according to the European standard. My general advice is to use vocabulary and domain model from the European standard, because there is a probability it will become a mandatory standard in the future. Of course, because of those differences, it might be quite hard to bring together those three models. So everything depends on your case. If you are a CPO, then it might be good for you to have a 4-layered model, because you can define different logic on each layer. But if you are an eMSP, it might be quite hard to present all the data in an attractive form to the end customer. Finally, I would like to present you some good to know things. First, let's focus on no delete policy and using full load operation instead. The main reason for using full load operation is because Hubject is versioning every dataset that was pushed to their platform. Because of that, you can see exactly how the data has changed over time, and you have a possibility to roll back to some old version of the dataset. Next reason is because delete operation is not the soft type. It will not create any kind of event, and it's hard to keep everything consistent. It's better to use full load operation to always update the latest dataset of, for example, EVSEs. Worth mentioning is that Hubject agrees on 24 hours eventual consistency. Therefore, it's possible to perform one full load operation in the night and do not delete single EVSE once it will happen. As I've told you before, direct communication with Hubject may be very beneficial. Not only you will understand their API better, but they can also help you in more complicated ways. For example, by providing a custom API. Let's take a look at the case with lack of authentication data for CPO. We have talked with Hubject about this problem, and it turned out that this operation was exposed before, but due to some problems and misunderstandings, it must have been removed from the API. Maybe they can cooperate and unlock this functionality only for your specific environment if that's what you really need. The delta pool last call parameter cannot be combined with other filterings like, for example, search center. According to Hubject documentation, there are some corner cases where it can lead to some data inconsistency on EMP side, but we do not know more details. Nonetheless, it's definitely worth to remember. When it comes to the pagination, it's good to know that the default number of records provided in paginated data response is 20 records. The maximum number of records that can be obtained in one single page is 2000 records.